In this, we are going to discuss the power supply performance and the testing. So the performance, so just now we have discussed the power supply, that is a linear mode power supply and a switched mode power supply. So after designing, we have to go for the testing performance, how the power supply is working. So a power supply is a component or a subsystem that converts your electrical power from one form to another, that is AC to DC value. And ideally this power supply is having a mathematical model for the accurate performance characteristics. But in the real world, the components are imperfect. In the practical implementation, the components are imperfect and the loads are vary, and the line power may be distorted, and if the environmental changes and which alter its performance. So for each operation we have to think these parameters, and we have to check the power supply performance. Moreover, the changing performance and the cost demands complicate the power supply design. So while checking the performance of the given power supply, we have to arise some questions, the basic questions. That is, the first one, how many watts beyond the rated output capacity can the power supply sustain, and how far and for how long? That is a basic question. If you design one power supply, the rated power is very important one, and how long it can be achieved. So that is the first one. Next one, how much heat does the supply dissipate? Here, due to the temperature changes, here we are having a electronic components. If the temperature changes, automatically the more heat will be dissipated. So how much heat does the supply dissipate, and what happens when it is overheat, and how much? So if you compensate, we can go for the cooling. So how much cooling airflow does it require? So these are the questions we have to arise. So first, second question. Third one, what happens when the load current increases substantially? So if you are taking one load condition, what happens if the load current increases substantially? So that is very important one. Next we can go for the line regulation and the load regulation. That is, can the device maintain its rated output voltage? That is for load regulation. Next one, what happens when the supply input voltage changes? That is for line regulation. So for the testing of performance, we have to arise these questions and answer these questions. That is very important in the while checking the performance of the power supply. So when selecting a power supply, either linear mode power supply or switched mode power supply, and some of the parameters to be considered, it is necessary to understand the various specifications. So before that we have to check the specifications. So what are the specifications? The voltage and the current specification, line regulation, load regulation, ripple and noise, and the temperature. Let us go with the one by one. Voltage and the current specification. So the primary power supply specifications are the voltage and the current output parameters. So in terms of the first one, in terms of the voltage, so it may be fixed or the variable output. So coming to the first one, if the power supply has a fixed output, there will be a small adjustment that can be made, and it may be necessary to check. It can be adjusted to the required value. That is, if the voltage required is not exactly that quoted on the specification sheet. That is very important one. If the power supply has a variable range, then it is necessary to ensure that it covers the required range. Okay, so it is related to the voltage. Next, in terms of the current, it is necessary to ensure that power supply will be able to provide the required level of current and have a degree of margin beyond that minimum requirement. So that is the current value in the power supply. Next, coming to the line regulation. So the power supply specifications for the parameter is very important one, line regulation. So what is a line regulation? It is found that when the line or input voltage changes, the small variation may be seen on the output. So when the input voltage changes, there is a small changes in the output, that is a line regulation. So this line regulation specification is normally quoted in millivolts and the percentage is 0.01 percentage. Coming to the load regulation. So another important parameter is load regulation. So again, what is a load regulation means? When the load is added to the output of a power supply, the voltage at the terminals can fall slightly. Okay, so this is obviously not desirable because the output voltage should remain exactly constant in an ideal world. So the power supply in the specifications for the load regulations maybe in terms of a few millivolts or 0.01 percentage. You have to refer these values in the data sheet. So it may be found that there could be a noticeable voltage drop along the wires from the power supply to the load. So this can be obviously reduced by using a thicker wires. So if you use with the thicker wires, so the we can go with the smooth operation. Next, the another important parameter is a temperature. So temperature is one of the main causes for the circuit conditions changing, and in the case of power supply, both the linear supply and the switched mode power supplies, it can cause changes in the output voltage. So when you the voltage references we can use it in the power supply designing of power supply, we can use Zener diode or IC voltage regulators can be one of the main causes of voltage change, but other electronic components changes as well, resistors being the main one of the reference diode. So this is a temperature. So it is often various forms of temperature compensation can be added during the electronic circuit design stages of the power supply, and this will be considered to reduce any drift, but there will be some changes and this can be adjusted. Okay, so this is a very important one. Even small changes can affect the circuit. So in this case, it is important to check the power supply temperature stability figures in the data sheet. Next one in this data sheet, and next one, ripple and noise. So the ripple and noise parameters are another important power supply specification. So it is possible that noise and other impulses on the power line can be transferred to the output of the circuit that is being powered. So in order to minimize this, especially for the sensitive circuits, it is necessary ensure that power lines as clean as possible. So that is important parameter in the power supply performance. Next, so the most good supplies should offer noise and ripple figures of better than 10 millivolt RMS, and for switching supplies, figures of 50 millivolt or less should be achievable in many cases, although very high current supplies may have a slight higher values. So the ripple on the output is combined as a single specification. For linear supplies, ripple frequencies normally be at twice the line frequency. For switching supplies, ripple and spikes will arise from the switching action of the supply. So while checking the performance, the designer is asked to create a power supply that takes up less space, more efficient, reduces the heat, cuts the manufacturing that is manufacturing cost, and meets the tougher the standard values. Only a rigorous regime of measurements can guide the engineer towards these goals.